Transformation of logarithmic functions. Okay, so in this exercise we have a parent function or root function that we'll call. So this is the one on the left hand side. y1 we call it is equal to logarithm to base 2 of x. And we need to transform this into y2 function, which is now defined as -3 logarithm to base 2 of -x minus 4. So the first thing is to define the domain of the original function, the range of the original function. And then we'll proceed to identify the domain of the new transformed function. So we need to recall that for the domain, x that we can use is real with the following condition: x must be greater than 0. So any positive number will do it. Not equal to 0, but greater than 0. The range of this function is a set of real numbers. So this is for y1. Now, knowing this, that whatever goes inside of a logarithm has to be positive, we need to proceed with the domain of function number 2. So let's call it 1, 1, 2. We know that this is going to be a set of real numbers, and then we have to identify the restrictions. So -x minus 4 has to be greater than 0. So let's write that statement: minus x take away 4 has to be greater than 0. Further down here, -x greater than 4. That would mean that positive x has to be less than 4. So this is how and why the domain is x is real, so such that x is less than 4. So no number 4, but anything that is less than 4. For the range of number 2, the range does not change when you do the transformation of logarithmic function. Whether you shift it left to right, so that is affecting the domain. But if you think about the range, you will never have a problem or change to it. So, because any logarithmic function eventually will cover entire y-axis. So the range is real. No restrictions, so y is element of R, and this is our domain, range. So now, let us begin with a graph of log to base 2 of x. So that will be approximately a curve that somehow looks like this. So let this be log to base 2 of x. So that's the parent function, y1. When you look at the coefficient in front of y2, it is -3. So let us think of 3 first. So that is a vertical stretch. So you go up or down, multiply it by 3 or -3. So let's assume that you see +3. So the stretch will cause that the x-intercept is still the same. The values will be tripled. For the same value of x, you will get 3 times as much. So it is not to scale. Don't worry about it. Just know the concept. So now, -3. So this is the reflection in x-axis. So -3 will give me the mirror image of that curve, which will look somehow like this. So this one here, we're going to call y. For now, we'll call it general y negative 3 log to base 2x. Now, if the base of the logarithmic function was different, let's say it was 10 or 5, overall concept would look exactly the same. So I use base 2 just to make it a little bit more challenging for us, so we can't be tempted to use our graphing calculator. But you will understand through this process here that it doesn't matter. The function will be slightly different when the base changes, so the features of the function would be the same. Now I want my transform function to be slightly rewritten in the following format. So y2 will be negative 3 log to base 2, and I'm going to take away the negative sign, so you have negative in front, so square brackets, and then take out negative, so x plus 4. Okay, square brackets. So this is something that we will be paying attention to. Function written in that format. So the negative coefficient in front of x causes the entire graph to be reflected in y-axis. So supposedly the value of negative 1 is here. So let us think of y is equal to negative 3 log negative x, log to base 2 of negative x. So now the blue curve will be reflected in y-axis. So you will see the mirror image. It looks more or less like that. So the line, the y-axis, is now a line of symmetry between the blue and the black. Now, let us look at the domain. Can I see something that I did something incorrect? This solution right here should give me negative 4. So my domain is x is less than negative 4. I apologize for that. So pay attention one more time. Negative x is greater than 4. When you divide by negative 1 or multiply by negative 1, you flip the inequality sign. So the left side will be positive 4 and the right side should be negative 4. Okay? So my vertical line should be placed close where that negative 4 mark will be. So this should be my vertical asymptote at negative 4. So since the domain says less than negative 4, so the entire graph should be located to the left with respect to of negative 4. So now the entire graph, the green curve, was shifted 4 units to the left. So every point on the graph is shifted 4 units to the left. Vertical asymptote also from 0 goes all the way 4 units to the left. The x-intercept at negative 1 is shifted 4 units to the left. So that will be negative 5. So let us go back to what we did from the beginning. So first we have identified the domain for the original function. Then by rearranging the transform function, we have extracted -1, so in brackets we have x plus 4. Solving this inequality, where negative x minus 4 or positive x plus 4 with negative sign in front is to be greater than 0, we came into the conclusion that the domain is real numbers where x is less than -4. So this coefficient in front of log does vertical stretch, because it's the value of it is greater than 1 if you don't see the negative sign. The negative sign, what it does reflect the graph in x-axis. Taking out the negative sign inside of the logarithm, we'll see that what it does, that negative sign, it causes the reflection in y-axis. And then, knowing that the domain is less than -4, so -4 becomes the vertical asymptote. So let's call it vertical asymptote. The equation of the vertical asymptote is -4, and since the domain tells us that you have to be less than -4, so you must anticipate that the entire graph will be located to the left with respect to that vertical line. So I hope you have enjoyed this video, and I'll see you next time.